Okay, what I'd like to do in this first thing is just to introduce you to why we don't like to use degrees, and why we would maybe start to like to use radians, and then just show you basically what it means to measure something in radians and how we might basically do it. First off, why don't we like degrees? Well, first off, where does degrees come from? The real answer is no one knows for sure, but the best explanation I've ever heard is it came from a Babylonian calendar. The thing about it is there were 12 months a year. Remember that the word month has the same root as the word moon, so there are basically 12 new moons a year. They thought there were actually 30 days between each new moon. So that gives you your 360, and that's it. And they would write the calendar as a circle, and so they were naturally, because of the calendar, dividing it up into 360 parts. That's not a very good mathematical reason. And it turns out when you start getting into calculus and you want to start applying some formulas, the answers you get in degrees are absolutely hideous. So degrees actually, I think, are fine for triangles. We're more comfortable with them, but we're only comfortable with them because that's what they introduced us to when we were growing up. I'm not anti-degrees. I'm just saying that if you start doing science with stuff in degrees beyond construction, degrees are not a good option. So that's number one why I don't want to do stuff with degrees. Now, to measure something in radians, remember what we're using is we're going to be using the unit circle. You don't have to use the unit circle. I'm just going to draw something like this, something very basic, and talk about what is an angle. Well, an angle is the same thing an angle was when we were talking about degrees. Yes, we always started here, and we always just started going around the circle and then stopped, and then somehow, some way, we measured the angle. Well, if we're looking at the unit circle, and we're going to be measuring the angle by this distance. Now, what does that mean? Well, we know the circumference of a circle, right, is 2 pi r. And since we're using the unit circle, it's just 2 pi. Now, what does that mean? That means it's about 6.3 all the way around. You only get to about 3.14 here. It's about 4.71 here. These are all numbers that you should have seen in trig. Basically, but when we're guessing, I usually call that about 1.6. That's about 3.1-ish. This is about 4.7-ish. This is about 6.3-ish. Now, if that's true, and I want the angle here, we tend to use the letter T just for the distance. If this is 1.6, then halfway is about 0.8. I would say that's about I'm saying 8.5 and I'm writing 5.8. Hope you guys are doing better today than me. Anyways, that would be about the radian measure. It just tells you how far to go. Let's draw a different angle. I'll draw this one in green. We'll stop in a different place and we'll just talk about how far it is. If I do this and I start going around and I go to say something like this, yes, well, that's clearly a much bigger angle. And what we want is about how far we would go. Instead of saying, well, it's more than 90 degrees, which is about right, I want to say something like it's more than 1.57. I would say it's probably more like 1.7. I know it's not all the way to down here. If that's 1.6, by the way, and that's about 3.1, halfway around there is about 2.4. So 1.7 sounds about right. And they'll say it's 1.7 radians, but all they mean that way is you're going to the unit circle and they're measuring how far they would have to walk around the unit circle to get to that point. Now, one more, we're just trying to get used to what's going on. Just like in degrees, we can go clockwise instead of counterclockwise. If I do something like, oh gosh, how do we go like all the way over to like this? But this time, we're going this way. So I'm going to draw something like this with an arrow. That's an absolute must in this case because I could have gone the other way. I'm going to say T is something. Well, what is it? Yes, if I had walked all the way back to here, it would be minus pi, or about minus 3.14. This is a little bit less than that. I would say about minus 3. Now, when you see this stuff like 1.7 and 0.85 and minus 3, how do you know it's not degrees? Because if it doesn't have the degree symbol, it's automatically radians. I'll say that again, yes. If you're using degrees, you have to have the degree symbol. If you don't put the degree symbol, it's automatically radians. All the software works that way, all the literature works that way, and that's something you need to get used to if you haven't done it before.